Right, right. So let's start by solving some examples. In example 1, find the equation of a line whose gradient is 3 passing through the point 0, 1, right? So this is, I think, case 7, where you are given the gradient and you are given a point. So we have the gradient of this line. Let's see. Divide it into 2 for me. Right. The gradient of the line is 3, and then the point, let's say the point is P 0, 1. When we have these two, how do we find the equation of a line? We use y minus y1 is equal to m into bracket x minus x1. This is the formula we'll be using. That means that we need to memorize this formula. So I'm putting it in the red box. That means memorize. Memorize the formula because you'll be using it very often. So y minus y1 is equal to mx minus x1. Let's substitute what we have in here into the formula. Y minus you should know that the points of P are x1 and x and y1, not y and y1, not y and x, right? So y is still y, it still remains as y minus y1. This is y1. Y1 is 1 from A and the P in the point we're given. So 1. And then the M is 3. That's the gradient. X is still x. And then x1 is 0 because it's from here to 0. Then we'll try and make it in this form, y is equal to mx plus c, right? Because that's the equation of a line. That's how it should look like, right? So we'll try and simplify it to look like this, right? Or like this, y minus mx minus c is equal to 0, or like this. It's still the same. So we could keep it that way or this way. Minus c. So we could keep it that way or this way. So let's see. So we have this, we expand this part of the equation. Y minus 1 is equal to 3x minus 0. So y is equal to 3x plus 1. Perfect. So that's the equation of the line. Let's see the answer they have here. Yeah, they have the same thing here. 3x minus 1 plus 1 is equal to 0. So you see they did this y minus this is equal to 3x, or right, there's or here, this. So you can choose to put it in any form you prefer. If they didn't specify the form in which you should leave your answer, you can just leave it anyhow. So you can leave it this way, you can leave it that way. It's still the equation of a line. You just have to simplify it to look simple. Make sure there are no expansions or brackets inside, right? Like this. So you get rid of the bracket and then it's okay. Now let's go to the next one. Example 2. A straight line has a gradient of, whoa, I can't see the gradient, minus 3 over 2, right? So the gradient is minus 2. That's example 2. This is example 1. Damn. Example 1. Right. A straight line has a gradient, so the gradient is minus 3 over 2 and passes through the point, the same thing, 4, 1. We've been given these two, we use this formula, right? So we use this formula again. So y minus y1 is equal to m into bracket x minus x1. Let's substitute. Y minus y1 is 1 is equal to x. M is minus 3 over 2. X minus x1 is 4. if you expand this, right, so we have a fraction in here, so let's multiply through by the denominator of the fraction, that's 2, to get rid of the fraction. So we're going to get 2y minus 2 is equal to minus 3 into bracket x minus 4, right? Then let's simplify it further. 2y minus 2 is equal to minus 3x plus 12. Right, so if I want to simplify this very further, so that would be 3x. I choose to bring this here plus 2y. Then I choose to bring this one to that side to minus 14 is equal to 0. This is also the equation of a line. Once I've removed the parentheses and then I've simplified all the terms, right? I've added all the numbers and then, right, there are no like terms, they are all different terms I can add. I cannot simplify any further. So that's the equation of the line that I have. So there are several examples in example 3 where we've been given the line, right? So we've been given the gradient and then the point, the gradient and then the point, the gradient and the point. So we'll use the same formula to find them. So this is when we have the gradient and the point. Now let's see if now in example 4 we see the next type. This is a type where we've been given the equation, we've been asked to find the equation of the line given 2 points, right? So this time we have 2 points instead of 1 and a gradient. We have 2 points and then we don't have a gradient. So how do we find the equation of the line this way? First we have to find the gradient of the line, then we'll use the same formula, right? So in example 4, in example 4, this example 1, this example 2, in example 4, we've been given the equation, the 2 points a 2 5, is it 2 5, it's 2 3, yes 2 3, sorry, 2 3, a is 2 3, yeah, 2 3, and then b is 3 6. So first we have to find the gradient. The gradient is given by y1 minus y2 over x1 minus x2. x1 minus x2. So y1, so we choose this 1 and then this 2 2. So y1 is 3, y2 is 6 over x1 is 2, x2 is 3. So we have negative 3 over negative, that is 3. Right. So the equation of the line is 3. The gradient of the line is 3. Now that we have the gradient being 3, we can use the same formula, right? Using any of these points. So I can choose to use P point A or choose to use this, right? You can choose any of them. So I will choose to use A because A comes first. I just choose to use A. So let me use A as my point. So I'll use the same formula used up there. Y minus y1 is equal to m into bracket x minus x1. So y minus y1 is from here is 3. I can choose to use 6, but if I choose to use 6, then x1 will be okay, but I choose to use 3. So 3 is equal to m, which is 3, then x minus x1, which is 2. Perfect. So if we expand, it will be this 3x minus 6, right? And then we'll simplify, we'll get 3x. I'll take y there to that side, so minus y. I'll take 3 to that side, so minus 3 is equal to 0. That's the equation of my line, right? That's the equation of the line I have. 3x minus 3y minus 3 is equal to 0. Right, so let's see if they have the same thing. Yes, they have the same thing here. 3x minus 3y minus 3. 3x minus y minus 3 is equal to 0. Right. We could use this way, or A simpler way to solve such such examples using y minus y1, right, is equal to x1 minus y2, y1 minus y2 over x1 minus x2. This is a more simpler approach, and this is a more simpler approach. This is a more simpler approach because it just puts the whole thing into one equation instead of finding the gradients like we did here. Instead of finding the gradients like we did here independently, right, on its own, with this one we put everything into one equation and find it because the gradient is this. So if you are using this, you just substitute everything and then we get this formula, the equation of a line, straightforward. So let's try this using this formula. Let's see. So we have 2 points, C with coordinate 1 1 and D with coordinate 2. Is it 13? Yes, 13. Right, it is minus 13. Minus 2 and minus 13. You know, 1 tries minus 1. This is minus 1. This is minus 13. This is minus 2. Is that what they are? This is minus 1. This is minus 2. This is minus 13. Because it's minus 13 minus 2 minus 1. So yeah, those are the points. If you can't see, use the test. Use the test book, right? So use the test. This minus 13 minus. These are the equations. These are the points. So let's substitute them straightforward into this equation. We have y minus y1. I choose to use c as my 1, right? It's very good to use the first one always as your 1. That way we don't need to think about it. You just take the first one as your 1 and the second one as your 2. So my y1 and y2 come from c, and then my x1 and x2 and x1, y1 and then x1 and y1 will come from c, right? So my x1 and y1 will come from c. So my 1s are from c. And x1, x2 and y2, all the 2s are from d. I choose to, right? Just that you should stay with it. You should stick to it when you choose, right? So y minus y1. What's y1? From these points, what's y1? Minus 1. So that's minus 1 is equal to y1, which is also minus 1, minus y2. y2 is minus 13 over x1 minus x2. What's x1? x1 is 1. What is x2? x2 is minus 2. So minus 2. And we have y plus 1 because of minus plus 1 is equal to, this is also plus. So this is 1 and minus 1 plus 2 plus 13, that's 12. Wait, I didn't finish. Sure. Then x minus x1. x1 is 1. Right, so it's complete now. Over 1 plus 2, that's 1. That's 3. Because this 1, this minus plus, so 3. X minus 1. If you make it simpler, it will be 12 over 3 is 4. Then x minus 1. Perfect. So y plus 1 is equal to 4 into bracket x minus 1. And we have to get rid of the parentheses, right? So y plus 1 is equal to 4x minus 4. To make it more simple, 4x, I take this and this to the other end, minus y. This goes to the other end, so minus 5 is equal to 0. So that is the equation of the line. And then it is here 4x minus y, 4x minus y minus 5 is equal to 0. That's the equation of the line, and it's correct. So these examples also use the same method. We've been given 2 points. So we'll first find the gradient and then we'll find the equation. Or you could just use this formula straight forward and then you have the equation together as one. Right. Right. So yeah, these are examples you should try all of them. You should pause the video Or yes, if you have the textbook, you just use the textbook. So let's see example 7. Example 7 uses the fifth or the fourth scenario. A straight line passes through the origin, right? It passes through the origin, right? It means the intercept there is 0, like it doesn't have intercept. And the point this, find the equation of the line. So when you have passing through the origin and then like that in this example, this is what you do. If you just find the gradient, right? But because it passes through the origin, the origin has, so that's example 7. Example 7. We know the origin itself is a point, right? So the origin has point 0, 0. That's the coordinate of the origin. And then we've been given another point, let's say P, that is -3, 6. So with these 2 points, you can find the gradient. So always when a line passes through the origin, you don't need to even use 2 of the points. You just use 1 because the other is 0, 0. So they found a gradient like 6 minus 0, -3 minus 0. Right? So it's -2. So the gradient is -2. Therefore, the gradient of that line is -2. Once you have the gradient and then you have a point, you can find the equation of the line. Right? So the equation becomes y minus 0, right? So I can use 0 as my point. Is equal to -2 to bracket x minus 0. So that's simple. Y is equal to 2x. Y is equal to -2x. So 2x minus y is equal to 0. Right, so this is a very simple way to solve it. Right, it's a very simple way to solve it. It's easier this way. Or you could also use the gradient, right? M is equal to y over x. So you just use this. So the gradient was -2 is equal to what? Y over x. Then you cross multiply, so you get -2x is equal to y. Then if you simplify, you get 2x minus y. Wait. The gradient is -2. If you cross multiply, you get 2x y plus 2y. Wait, it's not working. It's not working. I think this approach is wrong. Wait, why is it wrong? It's supposed to be correct. Yeah, because this is the same as this. Why? So why is it wrong? Wait. Right, so you can just use this. But wait, it's supposed to be correct. So it's not wrong. I made a mistake here. It's plus. Let's go that way. It's plus. Right, so it's plus. So if you remember, at that side, whenever there is in that video, whenever there is a line passes through the origin and another point, and you want the gradient, you use is equal to y over x. That's the formula you use. So a more simple way of solving this is just using m is equal to y over x. So we first need to find m, what we did here, to -2. So we have -2 is equal to y, which is a variable, over x. Please note that y and then x will always be a variable. However, x1, y1, x2, y2, these are the ones that will be substituted. But for x and then for y, they will always remain x and y. We need them in the equation. Right, so it will be like this. Then you cross multiply, we simplify it, so we have -2x is equal to y. That means y plus 2x is equal to 0. So this is a simpler way to approach this question. So there are several examples here. The equation of a line through this and this is this, where p and q are constant, find the value. So here we've been given some part of the equation and then we've been given 2 points. All you have to do is to find the equation yourself. cover your eyes over this side. So act as if you've not even seen it. Right? Assume we're not even given the equation. So find your equation. Then after, you come and compare your equation to this equation. When you compare them, then you find that when you find out what the variables are. There are other examples here. Intersection of lines. Right? So these are other examples you should try in finding the equation of a line, and then the answers are here. Right? Thank you.